Good afternoon, Build Stuff. Welcome back. We are live and online, and we are in person in Vilnius, Lithuania. Big hello to all the folks out there around the world watching us on the stream. Good morning, good afternoon, good evening, good whatever time zone this is for you. And any folks out there in the Southern Hemisphere, Australia, New Zealand, watching us in the middle of the night, we admire your dedication. Thank you for tuning in. So it is my great pleasure to introduce our next speaker here on the Jupyter virtual track, talking to us about how you can build data pipelines using open source. Please give a big warm Build Stuff welcome to Rustam Mehmandarov.
Thank you very, very much. It's really, really fun to be, at least virtually, in Lithuania. I mean, it's a lot of travel that I'm looking forward to, and I've used to come to Lithuania quite often. Then happened whatever happened last 2 years, and I haven't seen inside of an airplane for quite some time. So it's a great pleasure to be here. So thank you, Dylan, for the introduction. And today I would like to talk to you about data pipelines, and I kind of tried to make it more fun. I mean, talking about data pipelines can be less fun sometimes, but I tried to find some examples and cool things to show you, and to show you how you can build those yourself without too much of a hassle. And this talk today is kind of a bit twofold. So one, I'm gonna explain you how you do these things. I'm going to talk about an open source tool that will help you to do that. That's called Apache Beam. I'll get back to that in a second. But the second thing is, the second kind of part of this talk is to try to encourage everyone and any of you to kind of experiment with data, look for cool projects. And if you want to learn something new, like for me, it was to learn Apache Beam, try to find some kind of fun project that will make it possible for you. But, that's a little bit of a short introduction of what's going to happen. Let's get started. So, hey, Google, what's the bike availability next to me right now?
There are 5 bikes available at the moment. Based on historical data, the availability for this station will be decreasing for the next hour. I would suggest getting your bike within next 10 minutes.
That's cool. So I hope you heard what was there on I hope you heard the sound. I hope you heard the assistant talking. So this is kind of the way where we want to get, right? So this was kind of the final which product that we want to get. And now I would like to talk a little bit about what it is actually all about. And, so kind of a little bit of a rewind. So, this classic previously on or earlier in the series kind of slide. So the thing I'm talking about, the thing I'm going to, using as an example and as a playground for this kind of data processing, data pipeline thing, is bikes like that. So I think, so definitely the bikes you see on the right side are from Oslo. So this is where I live. I live in Oslo, Norway, where I work and live and everything. And the ones on the left side, I think they're from Antwerp. I think that was when I was at Devox Belgium at some point. And the idea is to kind of show you that those bikes are everywhere. I mean, I was in San Francisco. They had very similar bikes. I was in several other cities, like bigger cities. All of them had this kind of bikes. And the idea is very simple, right? They're public-ish, at least in Norway, it is like public provided service where you buy a membership, which is relatively cheap, and then you are entitled to kind of to borrow those bikes, use them as much as you want or within the rules or whatever, blah, blah, blah. But, the point is you get to use them, and then you put them into similar stations somewhere else in the city, and you're done. And then you can do it again and again and again. And the way they market it is like, this is like really nice pictures. So I asked them to send me some marketing pictures so I can use them in the slides. And that's what it was. So really beautiful, lakes and, and the sun and really nice weather. And, this is yet another one. I'm pretty sure this is very, very close to where I live, just out of the picture and everything. But, you get the point, right? Really nice weather, really nice bikes are there. You can just pick them up. You can rent them for the time that is allowed and use them and travel, and everything is nice. The thing is that Norway, which kind of probably quite similarly to Vilnius at some point during the year, it might look like this as well. So it's not always just, sunny and beautiful and amazing and awesome. And, the conditions might be different. And there is another problem, because all the pictures I got, all those kind of marketing pictures, they were like racks of bicycle, full of bicycles and everything. And that's really cool. But then when you actually try to get a bicycle, things might be a little bit different. So this is a picture I took, which is just across the street from where I work. And that wasn't a good day. And a few hours later, it kind of looked like this. So, I mean, it's the same rack. The only difference is there is no bicycle. So this is kind of, to give you the idea, it's the kind of same angle as we saw earlier. So bikes, no bikes. And that is kind of getting a little bit, that's where you get a little bit sad, because you bought the membership, you have this thing, you are actually having an appointment somewhere to get somewhere, and somebody expects you to show up at some certain time. And then you, get to the rack and there are no bicycles. So then you get a little bit, first you get a little bit sad, but then you get a little, this kind of geek wakes up in you and says, hey, wait. I know programming, I know stuff. I can probably solve it in a way that they are not letting us to use the data, the APIs they're providing and everything. So you kind of get to the planning board and to start to hatch the master plan, how to make sure that you will be able to have access to bicycles obviously in a legal way, and in kind of within the rules and everything, but still try to get enough data points to be able to predict stuff. So the master plan was kind of, this is the timeline and development of the master plan. That wasn't really very long timeline, but still, it's kind of just to share you my train of thoughts. The first one was, okay, well, we don't have bicycles. Okay, that sucks. Okay, what can we do about that? Can I find information about bicycles? Well, I mean, I don't really know, because, well, I mean, is there an app? Well, obviously there is an app, and there is a website, and there is all of those kind of things. But the problem is that all of those show you real-time data. And there is also a public API open for anyone who applies for kind of very simple process to get the developer API access and key and stuff. And, but again, the same API that is used by the app and the web that gives you real-time information. And that is kind of fine-ish. But the thing is, if I'm at home and I know that I'll be biking in 5 minutes, I can check and I'll see that, oh, there are 2 bikes available. Cool. By the time I get to the rack, to the bike rack, which takes me, I don't know, a minute or two, it will be, the chances are that there are some other people that have seen the same thing, and they see that there are almost no bikes there, and they will go and grab them before me. So that doesn't really work, right? Can I actually scrape, again, legally, because it's public API, developer API, can I connect that data and I can use it for something, can create some data points, do some predictions and stuff like that. And then, the geek yet again wakes up inside of you, and then you're like, hey, yes, I can do that. So how do we do that? But then, like, the next one, kind of so you have this kind of two people on, like, this Hollywood style thing. You have the one geek on the one side, and then the other one rational thinking person on the other side. And then the geek is like super happy about you going totally geeky and nerdy. And then the rational person, kind of the architect in you, wakes up and is like, wait, how are we going to do that actually thing? I mean, it's what's it going to be? And then you're like, okay, well, we'll probably have to put there will be quite a bit of data, so we need to put it in some kind of data warehouse or something. And then you kind of start thinking about, okay, how the architecture will look like, how things will be. So you get like, well, I don't know. And what kind of solution are you going to use? And then you start thinking about all those crazy enterprise solutions that you typically use, that you're kind of having experience with through work, through kind of working as a consultant and all those kind of things. But then you realize that those costs quite a bit of money, which you probably don't want to spend just to track your bicycles and stuff. So then you need to kind of retract and regroup, and just like before going into this field of bike hunting. So now we needed something kind of flexible and simple and portable, so we can first do what typically is known or kind of can be related to as ETL, so extract, transform, and load, and then we need to put it into something that will let us actually do something with the data, right? And then, well, obviously profit, which is not really profit, but you'll get your bikes, so you don't get money, but you get bang for your buck for the membership you paid for that thing. A few words about myself. So my name is Rustam. I, like I said, live and work in Norway, work for a company called Compitas, which is a consultancy company. I do all kinds of things. Mostly it's Java related stuff. It's mostly cloud related stuff. So I work quite a bit with that. I am a Google developer expert for cloud as well. And I am also one of the Java champions. So that's a very, very, very short introduction about myself. And let's go back to this big picture thing. So the big picture is, like I said, I work as a consultant, as an architect, I work quite a bit with cloud and everything. So it all started with a tiny Raspberry Pi on my desk in my living room, on the sofa table, like right next to my sofa, running all that, collecting all that information from an API and putting them all in text files and storing them on the SD card that Raspberry Pi usually uses for everything. And it kind of was a bit, it was okay-ish at some point, and then it was not that much. But the whole picture, the whole idea was to kind of create some kind of Lambda architecture. Hopefully we'll get why in a second. But then so what I set up on my Raspberry Pi, I created a cron job that will wake up every 15 minutes, an hour, so 4 times an hour. Sorry, every 15 miles. Yeah, well, every 15 minutes, right? So 4 times an hour, and then dump the data, so get the real-time data. Since I don't have any historical data, I had to kind of be creative somehow. So I need to process it with something, so something like Apache Spark or something that will do this transformation thing, converting it from big, ugly JSON files into something that I can actually work on, put it into some kind of data warehouse, so some kind of database, something that I can query and see trends and do all these kind of things. And then I need to preview it in one way or another. So I don't know, a notebook, Jupyter notebook, or could be anything else. It could be some kind of other thing that can semi-automatically, or hopefully fully automatically generate some graphs and availability and stuff like that. But then that was the batch part. But then I thought, what if I wanted to do streaming? So if at some point that API would offer me streaming as well, then I had to do a different way. So that was kind of the thing, like, okay, fine, if we go streaming instead of batch files and batches. So now I needed to think of creating a pipeline in Apache Storm or something similar, any product that you have an experience with or something. Again, put it into some kind of dashboard, warehouse, something, and visualize it somehow, right? So that was kind of the first version. And all that in one way or another was actually running as a tiny little Python script, and cron job and all those kind of things was running on that Raspberry Pi. The problem was that Pi didn't last too long, because SD cards are not made to be booted from and written to and read from all the time, so they have tendency to die. So then I was kind of smart enough to copy some of the data before it died, but then I lost quite a few months worth of data at some point. So then I wanted to kind of go, okay, one thing I wanted to merge those two pipelines. I didn't want to have one for batch and one for streaming, because, like, for example, I would, for example, add some data, say, I don't know, from weather data, because I would know if the weather is bad, that probably the chances of having a bicycle will be higher than good, nice, sunny weather, and things like that. And that might be coming as a stream, or, if they, like I said, offer streaming services at some point instead of just batches and files and stuff. So I wanted to create one pipeline to do both and to handle both things, and so I don't have to maintain two. So then I started looking around. That was kind of when was that? That was like a couple of years ago, 3 years ago or something. I started the whole project. And then I realized that there is this, I talked to a friend of mine that is working for Google. And then he said like, hey, have you tried this cool thing called Apache Beam? And I was like, yeah, well, no, I just heard about it, but no, I haven't tried, but I wanted to learn always. I wanted to learn about that. And then he said, well, you know, it might solve some of your problems here. And then I started looking into that. And then I realized that's actually quite cool thing. So what is Apache Beam? Apache Beam is a tool that was originally actually, well, you know, it was created by Google. It was open sourced by Google and given away to Apache Foundation. And it supports actually both batch and stream processing. And it actually supports a bunch of languages that they kind of wanted to use one of them. So it runs on Java, it runs on Python. They also have a Go API as well, SDK available. And the other cool thing is that it would support different ways of running it. So I could run it locally, but it would also be able to run on the cloud and all the other things. And cloud was actually getting to, at that point, it was getting more and more relevant for me because, you know, like I said, my Raspberry Pi died. I did not want to have it all local everywhere and only local. I wanted to be available everywhere, and I wanted to be kind of accessible. And also, yeah, well, you know, all those things that cloud brings to the table was really nice to have, but I didn't really want to that thing to cost a fortune. And, you know, I didn't want to build like a disk, you know, racks of disks at home and everything. I always dreamt of having like a rack of servers at home, but, you know, I don't think the rest of my kind of household shares my enthusiasm and maybe kind of have a little bit lower tolerance to noise and, you know, and all those kind of things. So that wasn't the option. So kind of I was more and more gravitating towards moving to the cloud. So that was kind of cool. And the swapping out part, well, the thing is that you can actually change both where you read the data from and where you write the data to different different endpoints using components. And that is, it can be Kafka, it can be storage, like buckets in Google Cloud or Amazon or anything like that. It can even be like Hadoop, and it could be also like PubSub kind of, you know, so you can publish the results or get the data from some kind of PubSub queue like thing, so message queue like thing. So then we kind of, the version 2.0 of this big picture evolved. So now we were putting, instead of writing custom scripts and custom things, so I had one pipeline to process all that using Java. So I wrote all that processing of my data using Java, parsing the JSON files, doing transformations the way I wanted, and storing them to, first I started with files. So I started storing them in files, and then I thought like, okay, I'll process them first. I'll figure out how to do those kind of things later, what to do with all that. So what kind of data warehouse and everything. So very quickly after this point, like I said, the managed version was created. So then I kind of moved to cloud. In this case, it's Google Cloud. It doesn't have to be, but Google Cloud provides the managed version of Apache Beam. So I didn't have to install it and create it and do all this kind of thing. So that was a bit nice. But it does, like I said, it doesn't have to be. It can be any other cloud, but then you'll have to do a little bit of more work to make Apache Beam run there natively. So here I had a cron job, again, like some kind of thing that would wake up 4 times an hour. I would store them in some kind of file system storage bucket thing. In this case, cloud storage can be like I said, S3 on Amazon or anything else. Then I could also process the same way if the data was streaming. Then I put it into a cloud data flow, which is a managed version of Apache Beam. So it was exactly the same code as Apache Beam. And then I could put it into data warehouse, which also got actually pretty much with data I actually have it for free, if I remember that correctly. So don't quote me that. I think it's for free, more or less. Actually, I think, It is for free, yes. So I put all that into BigQuery, which is a kind of data warehouse storage kind of thing. It could have been any other database or anything, again, if you're using some other cloud, or if you're looking to run it on your own machine or on-prem or something. And then, you could do an analysis using something, using like, Data Lab or something like that, or Jupyter Notebooks or whatever. But that was about the project. That was the idea, right? And then I started to learn. I wanted to learn more about the Apache Beam. That was kind of my first motivation to use all that, to process all this bike data. And I've been, like I said, I've been doing it for 3 years. And so you can imagine 4 times an hour dumping data. So, and I was getting 2 different files. I'll get back to that soon. But I had 2 files per call. And 4 times an hour, 24 hours a day, 365 days a year. And then, I had the 1 year, and then I had 2 years. And then, well, since I've been doing it for, I think now it's getting close to 4 years or 3-4 years now. And I had to create a pipeline because, to process that many files. And first time I started using that, I think I had 3, 4, 5, 6, something like that, months worth of data. And then I had to create a pipeline. So let's talk a little bit about pipeline. So what is a pipeline in Apache Beam? So it is generally in processing, it is a cyclical directed graph, and think of it as a conveyor belt, or like, this things you have in factories where a bunch of things enter the factory, like screws and pieces and, wheels and, glass and windows and things. And then at some point, there's a lot of magic happening within that factory, and lots of kind of conveyor belts going back and forth in one direction. And then at the end, the car comes out, right? So think of it as a kind of pipeline. So pipelines cannot be cycles, so acyclical, and it's a graph. So it's directed. So it has a direction. It cannot go in loops, and it has to go in, something goes in, something happens to it, and then something else comes out. And this is basically what it is in Apache Beam as well. And if you have to write a very simple pipeline, a very, very, very simple one, just to explain how the whole code part works in Apache Beam, and now we need to look into the input. So this is the very simple input that I had to deal with. So this is the information about the availability of bikes. So I get an ID. So this is an ID for a specific bike station, where the specific ID of a bike rack, and then it has 2 numbers. So it's a number of locks on that rack and number of bicycles that are available right now. So you can have like a rack of 24 bicycles, and it has 24 locks that are available, and it has 4 bicycles that is available, the first one, right? And you want to go from this kind of JSON file, which is quite long, and their APIs were not really perfect because they would just dump all data for all stations for all those racks into one big file. And I had to deal with 2 different files, the one that would connect this kind of information to a metadata about the station. So I would know actually which ID belonged to which station, if it was near me or it was somewhere else, and things like that. So I wanted to go from this, but don't think about the second file. We'll get back to that later. But like for now, we have this simple file, and we want to go to something tabular like this, right? We have an ID of a station. We have information about availability of bicycles and locks, and we want to know when it's been updated. If we go back again, you'll see there is no date here because the date stamp is all the way down. It's given you once. When you get the data, it will actually tell you when it's updated for all the stations. So you kind of need to do a bunch of transformations to actually copy paste kind of date for each entry. So this is what I did here. So the pipeline would be something like that. I would have input files. I read from those files, the JSON like things. I would parse them. I'll do a pardo. So I'll get back to what pardo in a second. So it's a parallel do, it stands for, which would parse JSON and create the data structure I wanted. Then it would use that data structure to change the way I wanted to move around data points and, you know, put together another structure, and it would store it to a database table or to a file or to anything like that. Data pipeline options. So that's like I said, it's 4 simple steps to create a data pipeline in Apache Beam. So the first one would be to create and define pipeline options. And those options are kind of things that you don't want to type over and over again. So it can be like, where do you read your files from? Where are you going to store them? What's they're called? What are they called? And what do you do? Do you have like some kind of a default string that will be used as a documentation or to show it actually on the screen somehow and things like that. And also what to do if things fail, or if there is, for instance, there is a failover. So if nothing is provided, if it's not provided as a command line argument to the pipeline, to the code, where to go to read the default data and stuff like that. So you define a bunch of those. I'll share you the link with the kind of properly working code so you can have a look at that later, but simply it's basically a bunch of annotations and getters and setters. Then you actually create the pipeline, which is one-liner. So you push the object, the options object into it and just do create. That's all. And then the third part, which is kind of the most important one, that's where actually the magic happens, is to apply all those transformations. And the way you do that is basically you say pipeline dot apply, you do something, you do dot apply again, do something else, you do dot apply and do something else, and so on, so on, so on. Then you can actually change those applies, change order of them, or, you know, and then you need to know what's going to get into that apply and what comes out of that apply. So you actually receive and use the right things. But that's actually happens more or less automatically for you. So that's kind of cool. So those pardos that I mentioned, pardos is element-wise transforms called parallel do's, and that's the kind of the beauty of it, because like I said, there was a lot of files, and if I had to do it in one go on one machine, it will take me quite some time, because one thread, you know, reading those hundreds and thousands of files, that might take some time. So I needed to have something. So that was one of the reasons I kind of wanted to go for something not homemade, was to kind of don't handle all this kind of threads and all this kind of things. And that was Apache Beam was offering as well, with the help of this parallel do's. So that is a set of codes that can be parallelized and run on many, many, many threads, machines, whatever, without interfering with each other, without making, you know, without breaking things for another thread, and without waiting for another thread and stuff like that. So a pardo, a simple one, again, like a very, very simple one for our case, was where I was reading and creating an object about station data, kind of can look like this. It actually does look like this. So I just create a new object that extracts data from JSON and returns me a data object from that. So that's it. It's not the prettiest code, but, you know, I still was playing around and wanted to learn Apache Beam. So it can be done more prettier, but, you know, that's what I landed on first. And the fourth step would be to actually run it. And running that thing, I mean, if you know Java, again, you don't have to be, it doesn't have to be in Java. My code is written in Java, but there are 2 other SDKs as well, both Python and Go. So if you prefer doing that, you can do that as well. But if you know, if you've been using Java, if you at some point, you know that you use a Maven Compile, so Maven to kind of compile and create packages out of your code, so you don't have to play around with Java path and all those kind of things. And it can also both put it together and also run it for you. So you do Maven Compile, you provide a few arguments to it, and those that are starting with D are, well, the P one is basically to say that we are going to use direct runner. That means that we're actually going to use our local machine and not all the other possible runners, like I said, because Apache Beam has this really, really nice way of, you can switch runners, but you can still have the same pipeline. So you can actually switch wheels of your car depending on what you're running on, in a way, right? So here we're saying, well, we're going to run it on locally, so we need the wheels that can run locally. And then you provide, like, you know, entry point for your program, so main class thing, and then where the input files might be if it's not provided as a default argument. But in this case, I wanted to provide that manually. And then you also provide where it's going to be stored and what's it going to be called. So that kind of bike title local, that would be kind of a folder for me. The cool thing, like I said, is that you can switch wheels without touching the rest of your car, the rest of like your actual logic for that, as long as your data doesn't change and outputs doesn't necessarily change. You can actually quite simply do that. So all I had to do to switch from running locally to the cloud was to do this. So instead of direct runner, I used Dataflow runner. So I'll go a few times back and forth so you can actually see the difference. You see that some things stay the same. So direct runner changes to Dataflow runner. The main class and args, they stay the same except for the value for the args, obviously, because now I have to provide a path to a bucket and stuff. Well, input files is a bucket now, and there is a few other extra files, extra options, sorry, needed for the cloud to run. So I need to provide which region it's going to be running on and where the temporary location for the bucket might be and how the output will look like and everything. But all in all, it's just a little bit different values, but it's just the same kind of thing. So you just need to change a few parameters and then you're good to go to run that. You'll obviously, to run it on the cloud, you'll need to have one extra thing set up on your machine, which will be like the authentication file. But if you worked with the cloud, you're kind of used to that, right? You cannot just talk to services in the cloud without some kind of proper authentication. But if you provide that file, you put it into your environment variables, rest happens kind of magically, automatically, kind of thing. So that was the first version of the pipeline. And first version was to process only one file and just process all that and pump it into a bunch of files. And here we processed, I think by that time we were around 6 months-ish worth of data, I think. Maybe 3, 4, 5, 6. I think it was around 6 months of worth of data. So it was quite a few files, but still it didn't take very long. But the cool thing is that on the cloud, it did spin up around 17 machines and process that in a few seconds. Instead of doing that, if I had to do it locally, it would have taken much longer time. And you know, each machine would have own set of those Pardos, so it would kind of it does all the splitting and everything for you, and it actually does that on-prem as well if you want to run it on-prem, but then it depends on number of cores and number of threads you can run on your machine and stuff like that. The output was like this, and that was kind of cool. And then we had around 1 million rows of data. So a little bit more than 1 million rows of data, which, I mean, it's not a big data, but, you know, it was getting there and it was kind of fun. So now I would process all that, pump it into a data warehouse solution, and then I would have, and also denormalize data like you would typically do in a data warehouse. So I can do some reporting and statistics and stuff like that. And as you can see, that's 2018. That's what, 3 years now from now on. So now I wanted to do a bit more crazy stuff. So now I wanted to join those files that I've seen, that we have seen together now, about with ID and availability and everything, with a metadata about each station. So the IDs would be the same, but it would contain different set of data. So this one says, well, ID 157, wherever that is within availability array on the left side. ID 157 belonged to this place, and it had these geographical coordinates and everything, because I wanted to be able actually to know where those stations are, and to actually maybe show them on the map, maybe do some other stuff. So now I wanted to merge two different files, and I wanted to create a much more denormalized kind of table now. And then I needed to, by that time, quite a bit of time passed again. So I had quite a lot of time, quite a lot of files now. I needed to process around 600 megs worth of files. And I actually did that a couple of times after that again. And, if I had to process again like that all of on my machine, that would have taken me some time. Here it went relatively fast. So now I had two starting points, and then I would do a merge at some point. So this is the visualization of the data pipeline. Again, that works perfectly fine on my own local machine as well. The reason I'm showing you screenshots is just to show you that it runs a bit faster on the cloud, and also this version of cloud has a really nice visualization of it that I don't get on locally. So that's a bit sucky part, but I'll show you my workaround around that as well in soon. So now we had much more data, we had more denormalized data, we had more information about each station, and we had also more historical data about that. So at this point, a year later, we were sitting around with 30 million rows of data, and that was 1 gigabyte worth of data. In the previous slide, we had 35 megs. The table size was 35 megs. Now we're already in 1 gigabyte. And when I run that thing, I got kind of a bit scared, because now as you probably saw on the previous slide, on this one we had 100 and something machines running all that, and that was quite a bit of data to process, and it did run for I think like 15 minutes or something to process all that. Because it was, well, my notes says, I don't remember that exactly since it was 2 years ago, but my notes actually say it was 5 gigs of data I had to process all in all at that point. And I was kind of afraid, because I got this thing in my console saying, you know what, now you actually use 900% more of your budget that you've previously used on this project. And the thing is that you don't see the final number until the day after. So I was kind of a bit concerned about, like, what's going to happen and everything. So now while I'm talking, you can actually try to guess how much, what was the number in euros behind that little black box there. So the day after I woke up, first, more or less, the first thing in the morning I did was to go into console and to see the actual final number. And that final number was 3.4 euros. That's I guess that's a price of 2 coffee cups or something like that in Norway, maybe even 1 if you're very fancy coffee, maybe 1 coffee, 1 cappuccino or something. So not that bad after all. And that was kind of cool, because I mean, I did see that crazy spike, but it did really, the reason that it spiked was that because until recently, I was running on pretty much zero cost, and now I had to pay those crazy amount of 3.4 euros, which was, well, yeah, that was wasn't that bad. But then you get a bit surprised, because you get a little bit, so you go from this depressed puppy to a kind of more surprised monkey kind of state. You're just like, whoa, I processed gigabytes of files, and I could process it on my machine locally as well, but it would have been much slower. Now I moved it to cloud, and just didn't really cost me much. So that was kind of cool, right? But then so far we have implemented, and I explained you this part of doing the batch processing. The cool thing is that I could have also go from batch to streaming, and streaming is a kind of different animal, a little bit different, well, quite a bit different, because the data is coming all the time. You don't have like a specific files that you need to process and then you're done with it. Your data can arrive at, for 8 o'clock in the morning, can arrive at 8 o'clock in the morning, but it can also arrive at 8:30. It can also arrive at, I don't know, 4:30 or no, 2:30 in this case, right? So you have to do a few other extra things you need to think about. And in general, you need to kind of think about, transformations, you need to windowing, watermarks, things like that when working with pipelines. I'm not going to go too deep into that right now because we don't have much time for that. And I didn't use that for my project, but, I'll just leave it there. And that's the point, is that you can do quite a bit of transformations. You can do element wise, you take one thing, transform into something else, you can aggregate things, you can do a lot of fun things. Yeah, this is how you put things into buckets. You can also put things based not on time, but also based on sessions, for example, if you're creating games and stuff like that. But that's a kind of a bit more of a trigger for you to, if you want to look further into the streaming part of that. Some cool features were that you can actually create queries without writing that much of a queries. You can actually do using code. You can say, well, give me a sliding window of past 5 minutes every minute, and that would be it. That little piece of code does that, for instance, right, for the stream and stuff like that. Here is an example of visualization. So at the bottom there, you can take a screenshot if you want. So there is a link to a post I created sometime earlier, where I actually tried to visualize local pipelines instead of uploading it to the cloud and looking at it. It doesn't look as pretty, but it's possible. You can also play around with dot language to visualize those. So this took me some time. It took a bit of digging to figure out how to do it. So I kind of documented it both for myself and for anyone might be interested in that. And then the other cool thing is that you could actually replace part of it. So you can change from storing to files to going to database by a very simple, like one kind of liner. So instead of doing that, you can just remove two last applies and replace it with an application to put it into data warehouse, into database. Yeah, so now that you've put it into data warehouse, you can do a lot of crazy queries. You can get a lot of data. You can do like statistical analysis. You can do trends. You can find the stations with the most broken bicycles. You can get, all this kind of things. And when, at what time, and which weekday things are looking how, and you can actually do much better decision making. And with all that, you just go create with all that data in the right way, with the same available historical data, you just, you get much better control than just this real-time application kind of thing. Yeah, and then you get to this kind of surprised monkey kind of thing again. You're just like, wow, I did all that, and it was really fun. So if you want to play around with Apache Beam, I would really, really suggest you to do that. A few warnings though. It's most of the time you will not be playing around with pipeline, but you will actually be trying to fix your data, because your data might break things and data might change because somebody changes their API and stuff like that. So with all this kind of transformation jobs, you end up hustling a lot with data more than playing around and building actually a proper pipeline. Yeah, and there are a few quirks that I have discovered that I'll probably we can discuss that later if that is interesting. All that code is open source, and it's like the pipeline I've built. If you want to play around, it's on GitHub, so you can find it there. And if you have any questions or any comments or anything offline, online, social media and stuff like that, you can find me on social media. So that's my handle on Twitter, Mehmandarov. That's my email. And yeah, well, that's all I have for now. That's all I have time for now, but we can talk for probably for quite some time about that.
Fantastic.
Thanks.
Thank you, Rustam. That was really interesting. I really love the kind of application of, I think often, people don't make the leap between the rental bikes across the street and then, cloud data pipeline services. And you're like, no, we can use those to fix those, which I really liked. So folks watching on the stream, anyone have any questions, please drop them in the chat. We have about a minute or two now to pick up and chat about those. And if we don't, I'll drop in the link for the live Zoom Q&A. You can go and have a chat with Rustam and over there. I've also just dropped the link in there to the GitHub repository where you can find all the code that Rustam was showing there in the demo. It looks like we have no questions. It appears you have achieved complete enlightenment and everyone understands everything now.
I wish I could do that to myself.
So the link, folks, I'll drop that in if you want to have a chat with Rustam or ask any questions about any of that. The live Q&A link is there. Rustam, thank you so much for taking the time to join us. Thank you, everyone
very
who's
much.
tuned in. All the folks out there in Vilnius watching us on the big cinema screen, and all the folks around the world watching us live on the Pine. Thank you for tuning in, everybody. Join the Zoom if you want to have a chat with Rustam about any of that. Otherwise, we're going to take a short break, and we will see you after that. Take it easy.
Thank you very much. Bye-bye.